Last session of the day is about prplMesh. I'll give some background on it, and I have been asked to make it short, so it's good that we already discussed a few things in the previous session. And then at the end there will be a demonstration. Those of you who don't want to see that may leave early, but I think it's going to be, I don't think it'll take a very long time, and it'll be nice. Okay, I'm going to start off by explaining what the Wi-Fi certified EasyMesh standard is really about. And now I have a beach ball. There we go. Yes, because it's an animated GIF. So the basic premise, I think everybody knows this by now, whole home coverage. The problem there being that if you have a single access point in the home, that's just not enough. It won't cover every nook and cranny of your house, and people will complain about their wireless not working, and if the wireless is not working, the internet is broken, and somebody should switch it off and on. Oh dear. So the solution for that is to have extenders. I'm trying to get it to go to the next slide, but it's not cooperating. There we go. Right. So, and now I pressed the button twice. Right. So problem number one, and in my defense, in the color scheme that I had organized, there was a number 1 on that, but you can't see it, is the whole home self-organizing network. There are solutions out there. There are many mutually incompatible extender solutions. Some of those might be hackish. One of the reasons being is that interoperability between different silicon vendors, especially when it comes to backhaul links, to links over which extenders are connected and have to relay traffic from stations, is not standardized. And that leads to some really, really terrible thing, like MAC address rewriting, which causes, wreaks terrible havoc as you have an IP address changing MAC address. Some using IP tunnels with all of its performance overhead, etc. And so people buy these things, they plug them in, the operator has no view of that, and when it doesn't work, who do they call? The operator's help desk, because the internet is broken, right? So not having a visibility there is a serious problem. So what's going in a little bit more technical detail on EasyMesh, there are two aspects, there are two different parts of EasyMesh. There's a controller and there is an agent. The controller is effectively what sends messages, what collects the network topology, the overview of how the network is connected to each other, connected together, which backhaul links, which control links you have, on which Ethernet port this particular device is connected, what the link quality is over wireless, what the speed is over Ethernet, which mobile devices wireless devices that you see attached, etc., with which signal strength. All of that information, that picture, is necessary to make a decision on a whole home self-organizing network. So you need to have that data in there. The controller is the one that does the discovery, does the onboarding of the extenders, pairing, and sends the messages to all the agents to try to figure out and continually keep state, and will configure them as well. On the extenders, you have then an agent running, and that controls the wireless access points, so the radios and the SSIDs, etc., that are configured on that, as well as the wired links, such as Ethernet ports and what you have behind that. This picture is a very typical scenario. You have a gateway, an internet gateway, connected via an access technology to the one. Itself typically contains an agent as well, because it typically has Ethernet port. Unless if it's a stupid bridge, it has an Ethernet ports, and it probably has a wireless access point integrated into it. In order for an operator to get control over the home network, the operators want the controller to be co-located inside the gateway and under their control in their stack. There are retail solution vendors who choose to not use this model and will deploy a controller as well, but that's not what an operator wants to see because of that basic problem of being able to have control, right? So the backhaul links you can see here are in blue. Maybe what we call backhaul then is the connections to the various extenders. maybe wired links, or then maybe wireless links. It's based on the IEEE 1905 protocol, which already existed for some power line adapters, was developed in 2013. 1905.1a supports G.hn as a standard as well, actually. But the EasyMesh protocol, or the multi-AP protocol, you heard people earlier today refer to it as MAP. That's short for multi-AP. That was the original name before the Wi-Fi Alliance came up with the marketing term EasyMesh. Funny story. This is what you get as a topology. So you have a gateway, and you have extenders connected to that, and an extender can be connected to an extender. It's not a mesh. Actually says that in the first paragraph of the standards. It is a tree topology. You can optimize the network by telling an extender itself, if it's connected to wireless, you can push it to another wireless interface to say that this uplink would be better, so therefore we will have better backhaul bandwidth. But what it is not is a true mesh in the sense that everything is interconnected with each other and every packet could go over everything. No, it's not as dynamic as that. All right. So the solution to the first problem of trying to get control over a self-organizing network is make a standard and implement it. Second problem is the management API. And there's a central configuration problem. So you have your access points today, they are standalone. You have a 2.4 and a 5 gigahertz radio, but typically dual band, dual concurrent. You can configure an SSID for it. You can set a password on it. That's all, and it does channel selection. That's all fine. But then you have a self-organizing network. So now you need to tell the controller to go and, when you configure an SSID, that it needs to distribute that to all the extenders. So that your clients can connect to any of them fully dynamically. This requires more logic, and this requires an additional API logic as well for that configuration, because there are just things that you need to be able to configure in there that you don't have in your standard interface. So what are you going to do? Are you going to try to extend your current API for configuring your local access point and extend it to add all the features to control a distributed network as well? Or, as typically happens today, do you define an API next to that to get access to that? That's a problem in itself as well, because then how do you decide which one to use? If you're a management platform, TR69, USB, whatever, if you're a mobile application, a web UI, which of the two APIs are you going to use? Are you going to choose that based on whether the end user has an extender or not? No. So the logical solution that we've come up for that is that, you know what, we need to converge to a single API. You always go through the controller. If you don't have any mesh nodes, even if you compile out all the extender logic and EasyMesh at all, you should still go through the same API to configure your local access point. I'm going to skip over some slides in the interest of time that are there just for illustration. They're not really necessary. Next part is okay, so now we have our API. But this is what it typically looks like. On the left, you see oh God, of course you see the letter. The text is gone again. So you see your management platform, OSS, BSS, and on the right you see a web UI or a mobile application. The three boxes in there refer to the three different software stacks. So you have an OpenWRT box, an RDK-B box, and Wouter stack number C, something proprietary. These are the two open source stacks. They all have completely different APIs to configure these things. They have other data models. Today, what is typically so is that for every model of gateway, you configure in your backend system an API to interact with to go to that. So those three boxes there are the different APIs for that. Same thing for a web UI. You do all your work to develop a web UI or a mobile application, then you buy a gateway with a different router stack. You have to start over again, or you have to dynamically switch between them. I remember, for example, the Orange application had a detection of which version of the software of which vendor was running on the gateway, and then after that detection, it would just use the correct API. That's horrid complexity. It seems completely unnecessary. So what we plan to do is that, you know what, in prplMesh we will have a common API and we will standardize it. And that means that you can reuse your development and you don't have the extra overhead of maintaining that and an extra effort of bringing on an extra type of target. Okay, so standardized management API, solution to problem number 2. I'm going to skip over that. That slide is a description of what it, well, no, I'll do it briefly. When I say a management API, it covers a whole bunch of things. We need to know the network topology. We need to have the ability to control all the mesh-specific things. We need to be able to control and measure the channel scanning behavior and configuring channels. Maybe doing a staggered channel configuration over the multiple nodes so that they don't, their channels don't overlap with each other if they're physically near to each other. We need to do the basic configuration of an SSID and that sort of thing, obviously. Whether it's an isolated configuration for like a guest or a hotspot versus one that is where the devices are allowed to talk to each other. And very important as well, we need to get diagnostics information out. It's really important for an operator to know what's going on in the home, because end users will call, they say my wireless doesn't work, and then what do you do if you don't know? It is starting to get very common to collect telemetry constantly. Have all sorts of information coming in from the driver, packet error rates, retransmissions over wireless, errors due to failure of authentication, association, and not seeing an authentication. All sorts of strange behavior that give you a hint that something is wrong in your network, wrong in your home network, that can actually be pushed up in the form of sending up metrics from time to time to a platform that gathers that data, or sending up specific alerts for an event that I've seen an authentication failure, something like that. Or I've seen a driver crash for all I care. So the data elements specification, which is a dependency of EasyMesh release 2, specifies actually those metrics, a lot of those metrics, and what to collect exactly, and tries to standardize those. That's in scope. We want to collect that as well. So this goes beyond simple configuration. We want to capture everything. Right. Then the next thing is complexity of wireless management. That's problem number 4. So in 2013, it was easy. Yeah? You had 11AC, dual band, dual concurrent, a few tricky bits here and there. But what's all coming at us? 11AX suddenly has the ability to simultaneously communicate with a station over 2.4 and 5 gigahertz. And then it has this OFDMA logic where you can use certain subbands to communicate with multiple devices at the same time. There's a whole scheduling logic in there. Does that work well? Are there maybe heuristics that you need to tweak based on the home network? On an extender as well, if you do a channel change and you have an extender connected to the backhaul, you had better coordinate that or you lose your extenders. So you have to make sure that you switch at the same time. Even worse, if you have a radar event here in Europe, everybody has to switch between in a matter of milliseconds. You better be ready and have configured which channel you're going to switch to, or have some way of notifying what you're going to do. Let's see. Then if you have a wireless backhaul link, that's the other thing. Now you need, an extender needs to be a station as well. So it has a station link upstream on its backhaul link, and it's an access point in the other direction. There are really some silicon solutions where the drivers don't even support that at all. There is all sorts of evolution in credential configuration, WPA3 for additional security, but also EasyConnect. New methods of pairing things are coming at us. We've had the hotspots and hotspot 2.0 for a while, agile multiband, which is a way of improving steering capabilities, also uses the same ANQP protocol. There's a lot of intelligence and that needs to be added into that. There are some low latency and QoS things that come into play as well, because now gamers want to use wireless instead of plugging in an Ethernet port, like a sane person. So we need to optimize on that as well. So there are also all sorts of things. So every single vendor has to go and implement, all of these things. Everybody has to work on that. why? How about we let prplMesh do all of that and track all of the evolutions together with hostapd, together with the Linux wireless support in the Linux kernel and the silicon vendors in a standard way, and the new features just come from the open source, just like they come from Linux to support new hardware, or they come from hostapd to support things like WPA3, which are there immediately as a first step. So common wireless management implementation helps. On top of that, you get for free that your behavior on multiple software stacks is now the same. Because you can maybe say that, oh, we're going to use a new gateway as an operator. It also has all of these wireless features, check, tick box in typical spreadsheet. And then it turns out that it behaves completely differently, and now you need to go and debug those things. If you're an operator, you've been there. I've certainly been there. If you have a common implementation, then you can trust that it will behave the same when you do a certain interaction on the management interface. And last but not least, the low-level API. But we've actually discussed it in fair amount of detail in the low-level API bit. So we want people to move to configurator to 11 so that we get rid of that. And that also, there's beyond the reduction of cost for everybody involved, it also overcomes portability impediments. It means that you can switch to another vendor or at least try them out. It's beneficial for everyone, really. So this is what that looks like then. You just have a standard data model in every stack running prplMesh as your wireless manager on top of hostap, that's hostapd and WPA supplicant to have the station and client station and access point support. On top of the netlink interface to configure it to 11, and there you have your device driver. Silicon vendor only doesn't have to do integration in every different stack anymore. So standardized driver, wireless driver interface. So prplMesh does all of these things. It's not just an open source EasyMesh implementation. Dave, do you want to do this slide? Is Dave Barr in the room? Yeah. So this is a bit of a background on the prplMesh project itself and who's been involved in that and what we've been doing.
Hi, I'm Dave Barr from Intel, and I just wanted to summarize the prplMesh project with a call to action. I've been pursuing many stakeholders to invest in prplMesh, and I wanted to explain some of the reasons why. Intel got involved because there were just too many software platforms. Each new customer would come to us with some peculiar software need, and it quickly saturated all of our development resources. So we tried to converge on a fewer number of software platforms, and so prplMesh and EasyMesh and prpl in general were great ways to do that. And we hope to get back on track by supporting fewer software platforms. Then we can take the savings and invest those in product differentiation. So if you're a chip vendor, those are the benefits. Actually, those same benefits would apply to everyone in the ecosystem, right? If you're spending less time reinventing common infrastructure, then you can spend more time on what you do best with your products. If you're an OEM, you get consistency and commonality between different chip vendors. So that makes it easier for you to switch between different chip vendors because it's your stack and not their stack. And in turn, the service providers gain consistency and commonality. It makes it easier for them to switch between OEMs because the stack is common. So those are all good things for all of us because we can work on what we do best. And in order to make this work, though, we need a larger team to build up because we have to catch up and keep up with the proprietary stacks that are trying to lock everybody in to a proprietary solution. So I've been going around and asking for stakeholders to contribute funding or software development resources, and I'm happy to report that for the coding tasks, we've had contributions from Technicolor, Intel Minim, GlobalLogic, Quantenna, Cable Labs, and we're also doing a fundraising campaign. And Soft at Home was an early investor. Verizon is a big investor now. And Intel, of course, is investing in CommScope, Vodafone, Smart RG, and Quantenna. So that's my call to action. I'll be approaching most or all of you to similarly invest in prplMesh. Thank you.
Yeah. Thanks, Dave. So that explains a bit how the team is organized as well. It's the largest project that prpl is running at the moment. It's actually funded, so prpl is funding developers as well as that we have other developers working in the same group from various companies. In the interest of time, I'm going to see if I can skip over go quickly over some of this. So it has to be it has a business-friendly open source license with a patent clause so that you don't have any concerns on that. The first goal is and it's just on GitHub. Anybody can build it. It's not hidden behind anything. The first goal that we set ourselves is to pass EasyMesh certification, Wi-Fi Alliance official certification. We have a testbed. For release 1, which is somewhat limited in functionality, but we have to start somewhere. First the controller, and we're pretty much there, and then the agent, and that's started. You will see after this a demonstration of them actually working for some of the use cases already. Platform independence, portability between stacks and the low-level API, you know that. Same thing with common wireless management. The reference target at the moment is, we actually have several. We started out by choosing the Turris Omnia because it's a great hardware target. It has 8 gigabytes of flash, 2 gigabytes of RAM. It has 5 Ethernet ports that you can use as WAN and LAN. It has an SFP port in which you could slot in a fiber link or something like that if you wanted it as a fiber router. And it has 3 mini PCIe slots, which means that we can swap out the cards. It comes, if you buy it online, it comes with 2 Qualcomm cards, one supported by the ATH9K driver and the other the ATH10K driver. But we've been able to slot Intel cards into that, for example, so you could just change those. The other interesting thing is that as we have a target to support this on OpenWRT and RDK-B, the 2 open source router stacks. Vendors of a proprietary stack are free to do their own platform adaptation and do their integration, but we're not going to do that for them. Just as it is possible to support a non-configured to 11-based driver, but again, that's out of the scope of the project. You can do that, but you're on your own. Because to support it both on OpenWRT and RDK-B, I've actually convinced the RDK-B community who were working on an extender reference target. And I've actually convinced them to use the Turris Omnia as well. And in the meantime, there is full RDK-B support for that target, including an open source Wi-Fi HAL for configured to 11, which means that we have the ability with a single hardware by doing dual booting in a test setup remotely or something like that, switching between the 2 stacks and seeing if behavior is the same. So there's quite a bit of value in that. Now, it's an expensive target. It's a bit of hackery to get it to work in the beginning. So we're looking at other targets as well, such as that Netgear RAX40, which has the Intel Wave 600 11AX cards in them. Minim is at the moment also porting it to a Qualcomm-based target that is supported by the standard Linux kernel, IPQ 4028, I think. And getting it up on that as well. So it looks like we'll soon have 3 different hardware targets running this already. Part of the scope, I've mentioned this, so I'll go quickly over it, is to actually bridge the gap and reach out to the community. We have pushed changes into configured to 11. We have pushed changes into host APD to be able to support this. They're aware and they're tracking this, so we get good support from those guys. We've reached out to the OpenWRT community. Some of them are in the room here. I am actually effectively the liaison with the RDK-B community, and we're following it up in there as well. We work with other standards bodies, so that standardized management API that you saw there is actually a cooperation with the Broadband Forum. Robin had it in his mesh, the OB map project. The open broadband multi-access point, multi-AP again, project is going to define the API for both, actually split into two components. One for the network topology, that could include other things than what EasyMesh can provide, and one for the management, the wireless management. So that helps us push forward the thing that this is a standardized API, because people will get this at some point in time as a TR from the broadband forum. Right, working with silicon vendors, and right. So then there's the question of where's the differentiation then? If we implement all of this, how can a vendor really make a difference in this space anymore? Are we killing innovation? No, we're not. What we're doing is we're doing a reference implementation of the EasyMesh protocol. We're standardizing how we manage everything. What's missing from that controller component is that, as per EasyMesh, it's only a protocol termination endpoint. It's a dumb thing that can just send packets and receive packets and keep state. It doesn't make any decisions of its own. So the intelligence is actually something that sits behind that API that we're defining. Typical features that you want to do is channel optimization, band steering between 2.4 and 5 gigahertz, client steering of a station from one to another. We'll do a demonstration of that later. And backhaul topology optimization to push your agents, for your extender from one to another to see that this is the best network configuration. That can happen by an external entity. Now, we're currently working on a code base that was mostly contributed by Intel, and there was some intelligence in that. We'll provide the ability to enable and disable certain features in there and configure them with heuristics at some point, but you don't have to use it. In this particular picture, for example, you have not what I was about to talk about, sorry. But what you can have, for example, is what I show here as the Northbound API is from within prplMesh, the API that we expose, that standardized API. There's some work ongoing on how we're going to interface with bus systems on different router operating systems. But once you're out on the bus, you can go through various protocol adapters and go through TR69, USB, whatever mechanism, go to the web UI to get to that API. You can do local components that have the intelligence to do that, and you can actually include other clients as well. We're working with the Plume guys, so there is, we're hoping to be able to integrate or have them integrate an open sync agent, for example, so that they can do all their cloud-based optimization. And anybody else is welcome to do that as well. We welcome everybody to join in that. What you see here as well is a westbound API. The westbound API is the operating system abstraction layer, because there's no perfect world. If you port from one operating system to another, where are you going to store your configuration? It's going to be different on an RDK-B with PSM versus an OpenWRT with UCI. So we need to have APIs for that. And as it becomes more advanced, we might need to reach out to the DHCP client to know if we have an IP address yet. We might need to configure QoS because the controller pushed that to the agents, whatever, right? Right, so this is that's the end of the presentation. Maybe I should ask if there are any questions before we do a demonstration. I have all the microphones.
Thanks. So my name is Dan Sills from Calix. Last week I was talking to a couple of people who are reasonably active in the OBMap, BBF's OBMap project, and they seem to describe, now I might have misunderstood, but they seem to suggest that the part of the Northbound API that I think now is called the Mesh Control API would essentially relay CMDUs or something, a close approximation. And when they said that, I asked, well, does that imply that the multi-AP plane controller functionality would be outside of the prplMesh integration layer box that you depicted recently? And they said yes. And I said, well, does that mean that if you employ prplMesh, you don't automatically get EasyMesh controller certification. And they said, yes, that's the implication. And so I had that conversation and I was confused at the end of it. I was wondering if you could comment on any of that. Like, did I misinterpret what they were saying, or what's going on?
I can imagine that there tends to be quite a bit of confusion, so it's an interesting point you raised. There are three different answers. So the first is that this Northbound API doesn't exist at the moment in the current implementation. We haven't implemented that yet. What we do have is an interface for certification. So you have the Wi-Fi Alliance test that has the ability to send commands to the controller to say, please transmit a CMDU, so that's a packet according to the multi-AP protocol, with this data in it, which is very, very low level, which puts a really low bar for the controller, but that's how the certification works. So that interface is there, but that's just for certification. We'll keep some methods of that active at some point in time in the future so that you can go through certification, you can plug in the test bed, but that's not the way we intend to use it. Now, second is that there have been calls for, well, this is a layer 2 protocol, 1905. It only goes over the local segment, Ethernet and wireless. You cannot route it. So if you want to have controller intelligence that sits somewhere out on a controller that sits somewhere out on the internet, you're going to maybe do a layer 2 bridge into some termination somewhere on the internet. That has been suggested. It's a terrible idea because there are response time requirements. You have to be able to the controller has to respond within so many milliseconds, and if you have some form of congestion on your access network, it'll go wrong. What is a possibility is that the controller would be somewhat of a controller proxy, meaning that it's a dumb protocol termination endpoint, but you can send messages towards it from a real controller at a fairly low level, sitting out in your backend, in your back office, and telling it to do all a bit higher level intelligence, but giving it enough state to respond to things that require low latency. That's also not really the approach that we're taking. We want to avoid that. We think it's even a security risk to be able to sit on the box or externally push CMDUs, because it effectively lets you inject frames in the home user's network, and that causes all sorts of concerns over what you could possibly try to do buffer overruns on agents or something like that. It could be an attack vector. So from a security perspective, we don't really recommend that either. So so it might be a bit of a confusion. We don't want to do that. The high-level API is really at a higher level. It's really like the TR-181 device.wi-fi data model. You set an SSID, you set your passphrase, and it will go and distribute it over all your agents. So the intelligence that's embedded in the prplMesh controller is more than what is strictly needed from the Wi-Fi Alliance certification. That's just not there yet at the moment. That's something on our roadmap. We'll get there.
How do we coordinate this is fantastic, right? So that solves a lot of problems. We can talk 5 more hours on this. I'll be very happy. But there are also parallel efforts. Some of them are overlapping, some of them are not overlapping. And WFA, USB, etc., and other places as well. So in your mind, what is the best way that we, instead of dealing with 3, 4, 5 different efforts, how do we make sure this effort is very well coordinated? For example, Broadband World Forum, right? Because this was just an excellent example, but the list is long. It's not just one thing. So how do we solve this problem of coordination? Who makes a decision, right, on what's the right architecture? There needs to be coordination. In your opinion, how should we go about that?
Are you talking about coordination at the protocol level or at the political level between people?
Well, to me, it's
layer 9 of the OSI level.
But to me, it's the same problem. Politics or technology is the same at the end. So
Well, I'll refer back to Dave Barr's slide. Please come and join us.
No, I mean,
come and join us on the
no,
calls and
no, let
provide
me-
us input
yeah.
on your use cases and have
Yeah.
the technical
So
discussion with us.
it's perfect, right? For example, our company's name, I'm not here to,
Yeah.
do commercial advertising, so I'm not going to mention name. But like my company's name was not on the slide, where another company just said that, okay, these are the companies supporting. But the data models came from us. We educate that company on how things are done, etc. And then there are other companies. So this is an ecosystem. There are many more companies, right? And maybe some of them are active in Broadband World Forum. Maybe it's here. And there are many, many, many small little topics that gets decided. So how do we coordinate this thing, right? For us, it's very simple, right? If it's not coordinated, then we have to go explain to the carrier 3 times, right? Why this protocol is better, what you should do, what we should do, and we have to do it over and over again 3-4 times. So I think you have good insight on this, so maybe you can speculate a little more on certain segments of the standards, how it needs to be coordinated.
So Wouter,
Does that fix the problem? I just added your company's name.
can I answer this one? And I think you're doing that specifically is why invest in prplMesh? I mean, this is why I got up earlier and said we're looking for the rest of the service providers to participate. Why? So that we can collectively look at this approach and align on it. Your name isn't up there today. It's an open forum. It's open standard. This is what our objective is, to drive this forward collectively and make sure architecturally we're providing that solution.
Great, so we joined another one, but I mean, it's not just us, right? It's basically, it's everybody, right? There's AT&T, Deutsche Telekom, Telefonica, the list is long. And to me, somebody who has invested over 10 years in this, I want things to progress a little bit faster, right? And you want to do the same thing. But this thing at the low level or high level needs to get coordinated. And I think a lot of issues, there's specific technical issues where we need to make decisions like, okay, do we do this or do we do that? Needs to be blessed by you guys, and also, right?
Absolutely.
So when AT&T says something, Verizon says another thing, and another. So
well,
it's very difficult.
but again, this isn't our objective. And I made a comment earlier. When is EasyMesh going to be service provider ready? I said, Rev 14 or something like that.
I see some people who are about to kick us out of the room. I would say it's very simple. Join us, both in, and I speak to your colleague Ken in OBMap, so he's already there. You're actually already involved.
My name is Nimrod. I'm from Intel. I'm managing the mesh activity in Intel, also called multi-AP. And what we're going to try to show you in this demo is actually different platform with different silicon vendors and different operation system, all running on the same mesh network using prplMesh open source code. Same code in all devices. This code was contributed by Intel to the prplMesh community about 9 months ago. And basically, if we look at the board, then we have 3 devices. We have a gateway and 2 extenders. The gateway is an Intel platform. It is located in the dining room, and if you haven't noticed it yet, it's a beautiful green box running RDK-B operational system, and also has a Intel Wi-Fi silicon that supports Wi-Fi 6, also known as Wi-Fi 11AX. This extender is a Touristomnia extender. It's located just outside the dining room, and it has a OpenWRT operation system. And the third device, which is the second extender, is an additional Intel platform, which is also running a RDK-B operational system. And actually, this Intel platform is a reference design for an official product that will be released by starting of next year in the cable industry. It's also called the XB7. So now my colleague, Tomer, which is also the prpLMesh maintainer, will connect a client that hopefully will be connected to one of those extenders. So as you can see, it is connected to this extender. And once it starts moving, then the controller in the gateway will manage the mesh network and will steer him from one of the extenders to another extender or even to the gateway. Depends on the channel that is currently the best one. So Tomer is now exit the room, and we need to see some kind of a change. A little bit drama. Correct, because it started with a far extender in 2.4, and then you go to the 5 gig. And now, as you can see, it's connected to the gateway. Okay, this is a Xiaomi client, and is now connected to the gateway, which means that Tomer is probably in the dining room eating a cake or something. So basically, we have a controller in the gateway that runs what we call an optimal path, and he asks the client to do measurements on each one of the devices, other devices, and according to some kind of algorithm that I can explain offline because we don't have enough time, he ordered the client to shift to a different device. And now that Tomer came back to the room, we can see that the client, this guy here, is connected to the extender in the far corner of the room. Any questions? Yes, please.
Very nice UI there, but I observed that when he came back, what does that two little circles represent? It's part of a different radio there? That on your screen there? What's the small circles?
Okay, the small circles is the right ones, or the dark green shows 2.4 gigahertz band, and the lighter green shows 5 gigahertz band. And you can also see the number of the channels. Channel 1 is a 2.4 gigahertz band, and 44, it's a 5 gigahertz band.
Okay, that's very nice demo. So basically what we saw is first client steering. When he went to that room, that went to the controller. Then when he came back, it went to the 5G first. Then when he sat down, it went to 2.4G, right?
Again, it all depends on the channel that is currently the best channel. We have people going in the room, people in the dining room. now people is going through the channel of the extender, so you cannot really anticipate what will happen, but the controller takes a decision according to a real-time measurement.
So, but that was a logical decision. So it went to the 5 gigahertz because he walked past the access point, and that was going to give his station the best bandwidth. Then as he walked farther away, as there is a sharper drop-off in 5 gigahertz, it band steered to 2.4 gigahertz, so it did exactly the right thing.
Thank you, Walter.